Now, in this section, we'll be dealing with the methods to measure the post-mortem time interval. As I've already told you, first of all, we have to take the body, the core temperatures of the body when we find a dead body anywhere, placed anywhere, and we have to take the samples from the dead body. For example, the insect collection from the dead body at the crime scene. That is the mainstay to the calculation of the post-mortem time interval. So the thermometry and the nomogram method. Secondly, we'll be dealing with the multiple site serial measurement methods. And lastly, the stomach emptying. The biochemical changes in the vitreous humor, they're very important. The nomogram methods and the post-mortem chemistry of the dead body, that basically tells us about how much time has been passed on after death. So the methods of measuring the body temperature. Whenever we find a dead body, what are the methods we can imply? The forensic team, the whole team, the doctors, the police, and the lab attendants that have gone there for the investigations, what methods do they take for the measurement of the body temperatures? First of all, you have to touch the body by hand, whether to determine whether it is hot, cold, how much time has passed on. It will give you a very beneficial knowledge to that. Then placing the mercury thermometer. We can place this mercury thermometer in the rectum, in the axilla, in the deep nasal passages, or in the external ear. Now, all of these methods are implied. The placing of the thermometer in the rectum. Now, this is basically, we have to identify what was the crime scene and what is it pointing towards. If there is any case of any homosexual activity, any sexual assault has taken place, if you basically are clinging on to that, then you have to basically the risk benefit ratios between placing this thermometer in the rectum, because strong evidence will be spoiled on if we place it over there, because the swabs has to be taken in that. If we are suspecting the cases of homosexual activity, we have to take the anal swabs for the chemical examiner, and that will be the mainstay evidence to this activity that has taken place before death. So in those cases, we can place the thermometers subhepatically. If there is a wound that has if there is a stab wound, if it is already present over there, we can place a thermometer subhepatically, and we can calculate the temperatures. Now, usually the thanatometer that is used for the dead bodies is graduated from 0 to 50 degrees centigrade. We usually place it in the rectum, and we have to basically remove the clothings and place a thermometer. And the graduated part has to be quite visible for the experts to record the temperature, and we have to leave the thermometer for some time. So because there are some changes that are occurring place, and to take a subtle temperature, we have to leave the thermometer for about 5 to 10 minutes to calculate it accurately. Now, there is another thing which is known as the rototherm thermometer. Now, the rototherm thermometer is quite beneficial, and it is basically, as the scientific advancements have taken place, so we have quite a digital type of a thermometer which is called as the rototherm thermometer. Then we have the thermocouples, of course, which are coupled upon some electrical devices, and they can also calculate the time interval since death. And then we have the microwave thermography to record the brain activity that can also measure the body temperatures. Then we have the infrared monitoring of the skin temperatures. So all of these scientific advancements that have taken place so far, all of these methods can be induced to measure the body temperature depending upon the type of the scenarios, the type of the crime scene that we are dealing with. Use of the thermometry in estimating the post-mortem time interval. Now, moving on, we can have one rule of thumb, and that is that the temperature fell about 1.5 degrees Fahrenheit, something under 1 degrees centigrade per hour. So this is basically a rule of thumb, 1.5 degrees Fahrenheit per hour. So fall in degrees centigrade from 37 degrees centigrade plus 3 was equal to time since death in 3 hours. So this is quite a simple formula. We have formalized all of this, follow the temperature to calculate the time since death. Now, there are methods which are known as the nomogram methods. These nomograms have been introduced and they are very important, but there are some constants to it. We have to say that the ambient temperatures was around 23 degrees centigrade, and on this nomograms we take the rectal temperatures, and on the other hand we have the ambient temperatures of the atmosphere, and then we can calculate by calculating the rectal temperatures, we can calculate the time since death by just looking at these nomograms. So they have basically simplified the investigations a lot. Now this is another nomogram, and over here the ambient temperatures are again 23 degrees centigrade, temperatures and time of death relating nomograms, the permissible variations of 95 degrees centigrade humidity. So the humidity is another factor which can basically influence the fall in the temperatures after the death. There are a lot of other factors, as I've already told you: the clothing, the type of posture the person was found at the death, the atmospheric temperature, whether there was any hemorrhage that took place before death or not. All these variables basically contribute, but still these nomograms are applicable, and they can be applicable to the calculations of 4 to 6 hours. So they're quite helpful actually. Now, the multiple site serial measurement methods that have taken place include using the multiple sites in the body for temperature estimations, and they're taken serially at frequent intervals over a period of time using highly sensitive thermocouples and computerized data acquisitions and calculations. So we have to basically get the temperatures at different sites at different intervals, and miniaturized sufficiently for the use at the scenes of crime. Now, use of the deep air canals and the nasal passages for the temperature measurings are still the mainstay in all of these cases, and we can still refer to them. Now, on a broader scale, we can say that the stomach emptying is also can be used as a measure of time since death, and digestion of an average meal lasted for about 2 to 3 hours. We have to keep in our minds that the digestion of the meal is the mainstay. So there can be particular variations when we are dealing with the type of food that the person has taken before death. So they can contribute to the calculation of the time since death. The influencing factors are the digestion continue for some time after death, the physical nature of the meal that the person has taken, of course, the nature of the food modifies emptying time, and the nervous or the systemic shock or the stress and the emotional state of the person at that time of death. Basically, all of these variables, they contribute towards the stomach emptying as a measure of the time since death. Now, use of the vitreous humor chemistry in estimating the time since death. The potassium, it is the mainstay. The flame photometry and the ion selective electrodes. The sodium is an ion selective electrode, another ion selective electrode. Magnesium and hypoxanthine, it is another ion selective electrode. Then we have the urea and the uric acid. It's an enzymatic uricase calorimetric. And then we have the creatinine, which has the same properties, and amino acids. They may have many sensitive methods how to determine. So these are basically the markers: potassium, sodium, magnesium, hypoxanthine, urea, creatinine, amino acids. These are the changes that are occurring at the biochemistry level in a dead body, and they will also help in estimating the time since death. So the post-mortem chemistry is the analysis of the physiological chemical constituents of the body as opposed to the toxic substances, useful in investigating deaths from the metabolic and the biochemical disturbances. All of these have to be, for example, the potassium levels in this diagram, as we can see, they rise in the vitreous humor after death. They have a particular pattern of rising, and that will contribute towards the calculating the time since death. So in this section, basically, we dealt with all the other different methods in which how we basically calculate the post-mortem time intervals. They can be the biochemical methods, they can be the taking the temperatures of the dead body, and the biochemical changes, the stomach emptying. All of these factors basically collectively contribute towards calculating the post-mortem time interval. Thank you for watching sqadia.com.